Hello and howdy, my fellow mathletes. It's Root Beer here, looking at the 2014 Manitoba Math Contest, and we are all the way up to question number 6. We are in the last half of the contest, although ideally, as we're writing this, we only have 2 hours. We should still be in sort of the first hour, because the last 5 questions are going to be harder and take a bit more writing than the first 5. Okay? So just it's something to keep in mind as you practice. How are you budgeting your time for questions? Are you leaving enough time at the end for the harder questions? That sort of thing. So question 6, a single digit A and a single digit B are placed on the left and right, respectively, of the number 731 to form the 5-digit number A731B. Now, because they've said 5-digit, I'm going to go ahead and assume A can't be 0. Okay? Maybe as I continue to read the question, A wasn't going to be 0 anyway, but if they say 5-digit number, I think it's safe to say that the leading digit is not a 0. Otherwise, it would be a 4-digit number, just written bizarrely. If this 5-digit number is divisible by 36, find all possible pairs A and B. Okay, so what does it mean to be divisible by 36? Is there a way to tell? Now, you may have, in your education, come across different rules to test whether or not something's divisible. Most obvious ones, divisibility by 5 is just a simple, is the last digit 0 or 5? Divisibility by 2, is the last digit even? Is it a 0, 2, 4, 6, or 8? Okay. Then there are more complicated ones. It's divisible by 3 if the sum of the digits is divisible by 3. It's divisible by 9 if the sum of the digits is divisible by 9. It's divisible by 4 if the last 2 digits are divisible by 4. It's divisible by 8 if the last 3 digits are divisible by 8. Divisible by 16 if the last 4 digits are divisible by 16. And there are ways to test if something is divisible by 11. And in general, if you have sort of a composite number, then it's if you break it down into its prime factors, then if it's divisible by each of those powers of primes, it's divisible by that number. Okay, so in particular, if I'm looking at 36, I don't know a general rule just by looking at the digits to test whether or not something's divisible by 36, but I do know 36 is 4 times 9, and I do know rules for that. So, 36 divides A731B only if both of these statements are true. 4 divides A731B, and 9 divides A731B. You can break it down however you want, as long as the factors of 36 that you're using are co-prime. So what I mean by that is, it's true if something's divisible by 36 that it's divisible by that number is divisible by. So 36 dividing into k means that 2 divides k and 18 divides k, but something 2 dividing k and 18 dividing k does not mean that 36 divides it. Obvious example would be k equals 18. But it does work if the two numbers that you use have no common factor. Okay, their greatest common divisor is 1, whereas for 2 and 18, that's simply not the case. That has the greatest common divisor of 2. Okay, and I'm not going to get into why that works. If you wanted to, you could write a little bit of, 4 and 9 are relatively prime or something like that. But I imagine that the markers don't really care either. Now, both of these have divisibility rules. The most obvious one, and the one that I find comes up a whole lot, is the divisibility rule by 9. This is true exactly when 9 divides the sum of these digits. Okay? So the middle part is 11, so 9 divides 11 plus A plus B. Okay, now what could 11 plus A plus B be? So I'm going to say 0 is between A and 9, and A is between 0 and possibly less than or equal to 9, and B is between 0 and 9 inclusive. So A plus B is between, it's got to be more than 0, and it has to be less than or equal to 18, because maybe both of them are 9. So then we'd have 11 is less than 11 plus A plus B, and then 29 here. So 11 plus A plus B could be, if it's divisible by 9, it could be 18 or 27. Both of those are a nice distinct possibility. Okay, so if that's the case, then a plus b is either 7 or 15. Alrighty. Okay, so what can we do now? We didn't get any other information, did we? Single digit, placed on the right, form 5-digit number. 5-digit number is divisible by 36. Find all possible pairs. Nope, no other information. Alright, so we just know a plus b is 7 or 15. Now we could start writing out possibilities, but we also have that 4 divides this number. And this happens, divisibility by 4 happens exactly when 4 divides 1b. Okay, so we could, say, well, what are the multiples of 4 in this range or anything like that, but really we just list them out. 1b could be 10, 11, 12, 13, 14, 15, 16, 17, 18, or 19. But in terms of being divisible by 4, it's just 12 and 16 we worry about. So b is either 2 or 6. So if a plus b is 7 or 15 and b is 2 or 6, a is either 5 or 13, or, using b as 6 now, a is 1 or 9. Okay, so a cannot be 13. That's not a single digit. But and how did they want us to write this? Pairs a comma b. So ab could be 5 and 2, or 1 and 6, or 9 and 6. Okay. There we go, 9 and 6. And these are the possibilities. They're the only ones that will give us a proper answer there. So we could double check. I mean, both of these add up to 7. This adds up to 15 here. And I'm just wondering, why is 7 and 15? I feel like 15 is a goof. Because it's 7 plus 9. They should be differing by 9, shouldn't they? And then, I don't know. See, there I made a mistake. 27 minus 11 is 16. So thank you for those who screamed, who were yelling at me through your computer screen. I managed to hear you. I didn't, but it's important to double check these things. And the numbers 7 and 15 were a little suspicious to me because they don't differ by 9, yet this should have something to do with being a multiple of 9. I was also trying to check these by adding this up in my head with the 9 and the 6, because the 9 being there fairly strongly says 7 plus 3 plus 1 plus 6 is supposed to be divisible by 9, and yet it clearly isn't. So this should be 16, and so that cancels out. So this should be 14, but that still isn't useful. So there, those are divisible by 9. Those have a difference of 9. Good, that makes sense. And b is 6. We get 1 or 10, which it can't happen as well. Okay. And so that limits us now down to 2 of these, and I'm a bit more confident they both add up to 7. 7 plus 7 is 14, plus 3 plus 1 is 4, so that is 18. Okay. But there were still ways to get a plus b plus 11 to be equal to 27. It just not with this extra constraint with divisibility by 4. All right, so that wraps up question number 6. Thank you guys for watching. If you are enjoying the particular Manitoba contest that we're doing, the 2014, feel free to leave a like. If you want to be kept up to date, for example, when I'm going to be posting my next video, feel free to subscribe and you'll be alerted when question 7 is up. So I will see you guys in question 7 whenever it gets posted. Until then, have a wonderful day.